breaks down on me. Right, this is the website, and I've given you the link to this website. And this is where we will be publishing all the content. I'm just a little bit nervous now, so I just want to check again. People can hear me and people can see my screen. Isn't that right?
Yes, both.
Yeah.
Right.
All good here.
Great. So I'm just going to start by giving an overview of the module, fairly quick, and then we'll get into some of the technical content, I suppose we might call it, which is going to be JavaScript. So let me flip over to my slides. So if you go into this part, you don't really need to, there are a set of slides behind this card here. You don't really need to go in there right now. I don't think you can if you want to, although it'll have to download a PDF, which can be a little bit slow. So, and hopefully lecture is being recorded, so you can go back and look at it if you want to. Right. So just to be sure, this is the module. Hopefully you've tuned into the right module. Enterprise Web Development is the module name. As it turns out, enterprise isn't really that significant in the title. The real focus is on the whole area of web development, and I have a link there, a URL to the actual website itself, which you already have. As I said, my name is Diarmuid O'Connor, and I'll be co-presenting this module with Frank Walsh. Now, this is kind of my one-liner. It's a long line though, but a statement of what the objectives of this module is. Sorry, just one second now. And so what is it saying? Design, implement, test, and deploy modern, secure web apps using industry standard frameworks, tools, and leveraging agile practice. Okay, it's a bit of a mouthful. The very first line kind of tells us that there is a strong emphasis on software development in this module. Hopefully that's to your liking. In fact, the vast majority of it will be of the software development nature. The second line, now I've kind of purposefully used a kind of a vague word there, modern. What does modern mean? And I'm going to spend a lot of the overview just explaining what I mean by modern. But it says modern secure web apps. So security obviously is very important on the web. Now, the only aspect of security that we will look at is just a proper industry standard authentication type implementations using something called tokens and OpenOAuth. But that's a little bit down the line. It's web apps as opposed to websites. So it's that kind of dynamic interactive experience that you might get when you're using an app that's running inside the browser. The third line, industry standards frameworks. Well, it's obviously important that whatever skills and knowledge you acquire in this module, they are, we hope anyway, immediately applicable to industry should you decide to go and work in industry after completing your master's. The last part are leveraging agile practices. That'll be more in the background than front stage, really. Really, what all I'm getting at there is, we'll be using version control as an integral part of everything that we do, but it's just there in the background. I'm not going to be teaching version control. Kind of assume that people might know a little bit about it already. Particularly, we'll be using Git. And you'll see that really from very early on, it will appear in all our labs. Frank will cover some technical stuff on the area of testing, because testing is very important in the whole agile software development methodology. But again, that will be towards the back end of this module. So that's kind of the one-liner. Now, back to the second line there, I'm saying modern. What the hell does modern mean? So okay, so the remainder of this little set of slides, I'm going to look at the context for this whole area, then talk about exactly what we are going to look at in the module in terms of technology, and just list whatever software you need to have installed in order to take part in the module. So, context. Now, it turns out that essentially there are two types of web apps. Now let's all be clear on what I mean by a web app and what we are going to mean by a web app. Your typical traditional kind of standard web app is your kind of online shopping type of experience. That is a web app that you are using as opposed to a website. So that's kind of that's what we mean by web apps. But within the web apps space, there are essentially two styles of web app, and it's style from an architecture point of view. The user doesn't know anything about these styles or architectures, but in terms of implementing them, there are essentially two approaches. There's what's called the server-side rendering web app, and that's what I'm kind of describing in this picture here. So on the left, I've got my client, which is my web browser. On the middle, I've got a server, which is doing a lot of work, and then on the right, I've got a database. So this is your kind of standard server-side rendering web app architecture. There may be a little bit more at the back end, but this will do for now. And the message I'm trying to get across in this picture is that the server is really doing everything. The browser is a blank box. We often refer to the browser as being dumb, or the client as being dumb, but the server is doing everything. In particular, the server is actually responsible for generating the user interface that the user sees in the browser. So the way these kind of server-side rendering web apps work is when the browser actually wants to load the web app into, when the user wants to load the web app into the browser, the request goes to the server. The server essentially generates the home page for the web app, in other words, the actual HTML and CSS, and it sends the HTML and CSS down to the browser, and the browser just displays it. If the user interacts with that page by maybe clicking a button, entering something in a text box, selecting a drop-down menu, any type of interaction will almost immediately cause the browser to send another request back to the server, telling it what the user has done, and what the server needs to do is decide what new user interface page should be constructed for the user. So what the server will do is it may consult the database to get some data, may put that data through some algorithms, and it will then generate the completely new HTML page and send that new HTML page down to the browser, and the browser displays it again. And that whole kind of sequence just goes on and on. So the browser has no role other than to essentially tell the server the user has interacted in some way with the page, and the server decides what to do with that. And each new page that the server sends down to the browser, there could be quite a lot of similarity between the current page and the new page, but that is lost really. The browser just receives a completely new page every time. So every interaction triggers that kind of flow that I've just described. That's server-side rendering, and where the name comes from is that the server is rendering the user interface. Now, the second category of web app is what is referred to as client-side rendering. And when I flip on to the next slide now, what you see is that this part here is going to move over here, as in that. Now the browser is actually doing something useful in this whole architecture. So for this, and this is what we call a client-side rendering web app. Again, as I said at the outset, from the user's perspective, they don't notice any difference. It's just the architecture is different. So when the user actually tries to load this web app into the browser, initially what's going to happen is the server is going to send down a lot of JavaScript code to the browser. And that JavaScript code is going to execute in the browser, and it will actually construct the home page within the browser, which the user now sees. When the user interacts with what they see in the browser, the interaction may actually be handled immediately by the JavaScript code here, and it will change what the user sees, and it will actually construct the change in what the user sees. It may, and often does, consult with the server, but its only purpose for consulting with the server is to essentially ask the server for some data. The server may consult the database, may put that data through some algorithms, and respond back with the result. But what is being sent back by the server in this case is just data. Whereas in the previous slide, when I was talking about server-side rendering, the server always returned the completely new HTML, CSS that should be displayed to the user. That data is received by the browser, and the functionality here is going to take that data and essentially stitch it into what the user is going to see on the screen. So we say that the client or the browser is actually rendering the user interface. And that's all done by means of JavaScript code. This is what I am calling the modern web app architecture. And this is where our focus is going to be. The original web app architecture was server-side rendering. Server-side rendering is still very important. Client-side rendering came along more recently, as in maybe 10 years or so, but where are we now, 2021, maybe about 2004, 2005 is where we saw this client-side rendering model. Because before client-side rendering, really, as I said, the browser was just a dumb client, and the browser is a very sophisticated runtime environment, so it wasn't really being used to its full potential. It is though in this model. So client-side rendering is where our focus is going to be. This is a little bit more detailed now, so we're focusing now completely on the CSR there stands for client-side rendering. And there are, quite often anyway, there are actually two servers at play here, and that's what I'm kind of representing here. So what typically tends to happen with client-side rendering web apps is when the user kind of loads the web app or tries to access the web app, what the browser is going to do is send a request to this server up here. This server is just a standard web server, static kind of web server. And what that web server is going to do by consulting its local file system is it will actually send JavaScript, CSS, and HTML. Of these three, the JavaScript is going to be very significant. The CSS maybe, the HTML is going to be very, very insignificant. In fact, the HTML may just be an empty web page. Those three assets arrive at the browser, and what happens straight away is the JavaScript starts to execute and fleshes out the HTML, fleshes out the web page using the CSS as well, and then displays the result to the user. Now, after the app has been rendered initially in the browser, from there on in, this part of the architecture is out of the picture. From there on in, the lower part kicks in. And as I was explaining earlier on, when the user interacts now with what they see on the screen, that may cause the JavaScript that's running in here to now consult this server. This server is now running what we call a web API. And the web API is only concerned with returning data back to the user. It also would have algorithms, maybe doing various kind of computations if that is relevant to the nature of the application. Now, in the second half of this module, E will be developing web APIs, see what's involved in developing this part. Essentially, in the first part of the application of this module, we'll be concentrating on the client side or the browser side. It doesn't really matter what HTTP web server you're using. It can be anything, Apache, anything else, it doesn't really matter. It's old technology, really. This is kind of the communication flow that I've been talking about there. So here's my browser, here's my HTTP standard web server, here's the web API server. The initial communication is between the browser and the web server. It responds back with the various web assets, JavaScript, as I said, again, a lot of JavaScript, maybe some CSS, and very, very little HTML. And once it has constructed the initial landing page or opening page for the web app, then all communication is back and forth between the browser and the web API server. Some of those requests are GET requests, that it's looking for some data. Some of it may be POST requests. So typically maybe here the user has filled out some form of some nature and submitted the data. As we know, that's going to be a HTTP post request with the actual data that the user has entered, and it's processed in whatever way by the web API. I've held on to the label modern there. I probably should have changed it now to client-side rendering or CSR. They've been around for a while, and this is just my kind of very, very high level summary of the whole client-side rendering web app space. So kind of emerged initially back around the early 2000s. I'm saying 2004 there, the Gmail was one of the earlier kind of web apps, or one of these web apps that followed this client-side rendering module architecture. YouTube, the very first generation of YouTube was as well. It has since gone through many evolutions since though. Now back around these days, your client-side rendering web app, you found yourself writing a heck of a lot of JavaScript code. And I'm saying here that the whole developer experience, the developer experience now as opposed to the user experience, the developer experience was very frustrating and unsatisfactory. The volume of code that you wrote was enormous, really. It was very unmaintainable, I suppose, really, because there was very little knowledge as to how you should structure. All of the code, of course, was written in JavaScript now in the browser, because that's all the browser can execute. You found yourself writing an awful lot of JavaScript code. There was no real good understanding as to what kind of patterns and structures you should put on that JavaScript code. Inevitably, it became very unmaintainable code. Also, the code that you wrote, the JavaScript code that you wrote, tended to be browser vendor specific, or if you wanted it to be cross-browser, you had to actually build that into your JavaScript code. So maybe your JavaScript code had to kind of detect what browser am I running in, and then adjust accordingly. Also, what I'm saying here is that these early client-side rendering web apps lacked addressability. Addressability is one of these standard key principles of the web. You know, in the static website world, whenever if you're navigating a static website now, and you click on a link and a page changes, the URL in the browser's address bar changes as well. So for every page that you navigate to in a static website, each page has its own unique URL. That's what we call addressability. And the real nice aspect of that is that if I wanted to make you aware of a particular page within a website, I could give you the direct URL of that page and you could go to it immediately. You didn't have to go to the website's homepage and then have to follow a particular procedure to get to the particular page that I wanted you to see. That's this addressability quality of the web. It's a fundamental quality. Now, in the very early kind of versions of client-side rendering web apps, that addressability didn't exist. The URL in the browser never changed, even though the view of that the user was looking at was changing, the URL wasn't. A really significant library called jQuery came on the scene then. What am I saying? Did I put a date on that? 2006. Okay, so it was around only 2 or 3 years later, really. And what jQuery addressed was the whole developer experience, and it addressed browser incompatibility. It took care of it, really. jQuery is and was phenomenally popular, mainly because, you know, it made the whole developer experience for developing these client-side rendering web apps just a little bit more bearable. And as I said, it also handled browser incompatibility. So your web app, your client-side rendering web app could now run in any browser, there or thereabouts. We still had issues with code maintainability though, and we still had issues with addressability. They still weren't being dealt with. Move on to something called single page app frameworks. The name now is kind of odd, and it's only later on I will be able to explain to you where this name single page app comes from. But essentially, what these frameworks did was they addressed these two remaining problems with the development of client-side rendering web apps. And this is where we are at the moment. We're in the, if we want to develop client-side rendering web apps, we use a single page app framework to help us in that development process. 2010-ish they came out, so they've been around for quite a while, but they have gone through a number of evolutions since then. Okay, I'm just going to stop for a second. I'm doing a lot of talking. I know if people have any questions so far. No? Okay. It's all a bit woolly, admittedly. So that's the context anyway. So we are going to be using, so what I can now state is we are going to be using a single page app framework for developing a client-side rendering web app, and in particular for developing the front end part of a client-side rendering web app. Back to this picture that I showed you. And so in the kind of first half of this module, we're going to be focused on this part of the modern web apps architecture. We're going to be focusing on the client side. We're going to be using one of the single page app frameworks out there. And by far and away, it is the most popular one right now. In 5 years' time, it may not be. It may not be even in less than that. That's the whole nature of this area. It does change, certainly within 5-year blocks and maybe even shorter than that. But right now, it's fairly significantly ahead of its two main competitors. And the single page app framework that we'll be looking at is a framework called React. You may have heard of it. The other two main competitors in this space are Angular and Vue. Angular is the oldest of those three, and for a while, for a number of years, Angular was number one. In fact, I'm pretty sure I taught the Angular framework when I was teaching this module a number of years ago, but you know, things change, as I said. And in very simple terms, all React is a JavaScript library for building user interfaces. Sounds fairly simple, but there's quite a lot to it, as you'll see when we get into it. On the other side of the architecture then, the server side, where we develop what are called web APIs. What technology are we going to be using on the server side? There's a lot more choice here, and there isn't necessarily a clear leader either, to be honest. But what we're going to use is a combination of what's called Node and Express. Node, as you may know, is a platform that allows us to write JavaScript on the server side. I think I mentioned it there on a previous slide. I might have skipped over it actually by accident, but essentially that's what it is. Node came on the scene around 2009. Prior to 2009, the only place you could execute JavaScript was in a web browser. And Node was a revelation, really, because that really allowed us to now write JavaScript on the server side. Express is what Express could be classified as a framework for developing web APIs. Again, also in the database side, we could really have chosen any number of databases. We're just going to use MongoDB. Again, you may have heard of it. It's what's classified as a non-relational database or NoSQL database. That would be really around week 10-ish, so when that would be introduced. So that's quite a period away. When you are designing web APIs, there is this architecture called the REST architecture, representation state transfer, which is a bit of a mouthful and kind of meaningless, but essentially REST is an architecture style for designing the interface to web APIs, as you see. So this is how we could view now what we are actually going to be doing. we are going to be using what's called the MERN stack, MERN, where MERN stands for Mongo, Express, React, and Node. And so the React side is going to be running in the browser side, in the browser. The Node and Express is in the middle, server side, and Mongo is on the extreme right. Node is a platform, as I said, that allows us to write JavaScript on the server side. And so that means we are going to be using JavaScript on the server side and JavaScript on the client side. So that's nice. Just one language. Mongo, actually, as it turns out, is essentially kind of a database for storing JavaScript objects. So really, it's kind of JavaScript from end to end, which makes, I suppose, learning that a little bit easier for us. But as I said, we could really have chosen anything on the middle. Like we could have chosen a Python framework or a Java framework or a Go framework, all of which are very popular, but then trying to juggle two languages in the one module mightn't be the best idea, really. So this is why we're sticking with the Node Express in the middle. So here we are. The module's focus is going to be single page apps using React and web APIs using Node and Mongo, and Express not mentioned there, but. And I did mention these agile practices. So we'll be covering a little bit on automated testing, mainly on the web API side, not on the front end side. Although there are nice kind of automated testing frameworks for testing web-based user interfaces as well. As it turns out, we're going to be using source control in the background really at all times, Git in particular and GitHub. I'm not sure whether we'll get onto continuous integration or not. I did cover it 1 year, but we'll see as to whether we'll be able to cover continuous integration. But you may or may not know that these are all practices that are very common in the whole agile development process. You've done a lot of well, some of you may have done the agile module in the previous semester, so these terms would be very familiar to you, and we're kind of more piggybacking onto that really. All that's left now is just to mention, yeah, this is roughly enough. This is how things are going to pan out, and I've kind of already mentioned that. Now we are assuming people are coming in with no knowledge of the web, which is unlikely, but anyway, that's okay. So we are going to cover the foundations fairly quickly. Maybe in the first 2 weeks, we'll cover the foundations that are necessary. The foundations being JavaScript, predominantly JavaScript, really. A little bit on HTML and CSS, but really, it's highly unlikely you haven't seen any HTML and CSS or practiced it prior to this. JavaScript, we're kind of assuming that people have not covered JavaScript before, even though you probably have, but we are also assuming that you're confident programmers, so we can cover the JavaScript language pretty quickly. We don't have to go into the very low, very kind of low level fundamental parts of programming languages like loops and iteration and all that kind of stuff. We're assuming all of that. So it's mainly the syntax of the language that we'll get through fairly quickly. And then we move on to the client side and then the server side. What's left then is what software do you need to install for this module. Now, I am going to be using, and Frank really are going to, we're both going to be using VS Code as our text editor. It's not essential that you use that. You may be more comfortable with, I don't know, WebStorm or something else, but I think it would be a good idea maybe if you haven't come across VS Code before to start using it with us. It's very easy to get familiar with it. It's a very simple download. So you will need to just, it's essentially just a zip when you download it. It's a zip and you unzip it and voila, you have it. Now, once you install VS Code, there may be other extensions that we will need, a couple, not that many along the way. So, but the initial installation is very foolproof, really. So if you haven't already got it, then you might just grab that. Obviously, you need to install Node. You may already have Node installed on your machine. If it's reasonably recent, then it should be fine. This is just a screenshot from the Node website that I took last week. So we're up to whatever version 14.15. something. Make sure, if you haven't got Node already, make sure you pick this one here. Do not pick the one on the right. The one on the right is more kind of leading edge and may not be necessarily bug free. It's more kind of experimental, which some people like, but not for us. Make sure you pick the one on the left. We will be using Git, as I've already said a number of times. So again, you may have Git already installed on your machine. Just type git space minus version, I think, to see if it's already there. If it's not, then go to this website here to install it on your computer. Just be comfortable with the DOS or the terminal command line, because we'll be using it every now, quite a lot, but that shouldn't be an issue really. That's what I'm getting across in that slide there. VS Code, this is actually a screenshot of the VS Code layout. So on the left, we have what it calls the activity bar. So there are different activities. This is the editing activity. This is the Git activity here. VS Code has really, really nice integration with Git. These are the two main activities that we'll be using. So you'll be flipping between those two. This one down here is where you click on if you want to install an extension. Down at the bottom, we have what it calls a status bar. Then this is the editing area, and here is what it calls panels. What VS Code has is it has an integrated terminal panel. So you can actually open up a terminal, or whatever you want to call it, a DOS session or a shell within VS Code. So you don't have to be flipping between VS Code back to your shell prompt window, back to VS Code. You can do it all within VS Code. You can open up a terminal session here, which we will be doing, using a lot of really. Yeah, just as I said, be comfortable navigating around your file system using the CD command. That's all. I'm not going to talk my way through this slide now. I'm assuming people are comfortable just navigating around their file system from the command line rather than doing it through Windows Explorer or any of the other kind of UIs. And that's it, really. That's my overview or introduction. I'm not going to talk through this, but that's just a summary of it. I've gone through a lot of technical terms, which I'm sure are all pretty vague. If you haven't been working in the web space for quite a while, this may all sound a bit overwhelming, but let's not worry about that. We'll get through it all right. But I'm just going to pause again for a second. The only thing I haven't mentioned is assessment. I don't like talking about assessment on week one, but people always would like to know. Essentially, there will be two assessments. It's a 100% CA module. There'll be two assessments, and it's fairly predictable. One assessment will be to develop a front end or a client, and the second assignment will be to develop a web API for your client. What we'll actually be doing in the labs is, in my labs, we will be incrementally rolling out a front-end web app using React. And then you can either take that app that we've developed in the labs, that front-end browser-based app that we've developed in the labs, and extend it further. And I'll give you some ideas as to how you can extend it. And I'm sure you'll better come up with your own ideas. Or you can take a completely different kind of problem space and develop a front-end React app for that. But again, that's a bit down the line. So that's the first assignment, and the second assignment is to develop a backend and database backing that client side. I'd say I don't want to be mentioning deadlines now, but it will take us a little bit of while maybe to get comfortable with the whole React kind of programming model. So I might give out the spec around week 4 or 5-ish maybe. But you will need we'll give you maybe the majority of the remaining weeks to get that working, and you'll probably be developing maybe the web API part, the backend part, from kind of week 13 to maybe 11, 12, 13, 14, that kind of ballpark. I'm going to pause again and just give you a chance to maybe to ask me any questions, whether it be specifically about technologies or more general stuff that more kind of introductory general stuff that I haven't covered. Is there anything?
I just want to find out, in terms of this project, do you tell us what to build, or can we build anything?
You can build anything you want to. I would hold off on it until we have at least some ground covered on React, so that you have a sense of what's possible. But it's completely open. You can build your own. If you've got an idea already, yeah, you can start thinking about it and sketching out the look and feel of the UI of the particular problem domain that you're addressing. Or if you're less comfortable with, or if you may not have any specific idea, then, as I said, you can take the app that we've developed in class and extend it further. And there's lots of scope for expanding it further.
I'm just working on a personal project that I could probably apply to this.
Yeah, sounds brilliant.
And then in the terms of if we have things like AWS step functions or API gateways, could we use other things?
You could. So the way those things tend to work is the old model was that you had a single web API where all of the functionality was kind of mounted on one server within one container. Maybe the newer kind of microservices based model, as you know, is where you break up the web API into multiple microservices, maybe using Lambdas on AWS. I think we might be open to that. That's kind of Frank's area, so I prefer to let him make a decision and guide you on that. But initially, I'd say he'd be open enough to it, subject to maybe some requirements that he might put on you.
Yes. I'm just curious because I have been exploring it. So there's Docker, and then there's also Lambda, and then you get other things that are like gluing all these things together. So
yeah.
I'm just wondering.
Yeah. I've been playing around a bit with. You didn't do the cloud architecture module, did you? That in the first semester, or is this your first module?
No. I'm certified on AWS, so I do know.
All right. Okay. Yeah, I think maybe if you just hold off on that side for a little while and speak with Frank about it. I mean, you could actually contact him on Slack straight away with your ideas, because it sounds like you have some ideas already. So pass them by him, really, and he'll get back to you on it.
Okay, because I am building something. Okay, great.
Yeah, that sounds great. Anybody else have any other questions?
Hello, I have one question for you.
Sure.
Actually, two questions. First of all, how do you pronounce your name?
It won't be in the exam. My name is Diarmuid, so it's a Gaelic name.
Yeah. Okay. Diarmuid.
Yeah. Okay. Diarmuid. Yeah. Diarmuid is actually a better pronunciation, and it's not Dermot. Dermot is a very different name. A lot of people, Irish people, even call me Dermot, and they're two completely different names. They sound similar, but anyway.
Perfect. So my other question is, when do you plan to release, in the module, the next labs, or the presentations, the PDFs that you're going to give us? Would it be possible, to give everything at once, or do we have to wait? Each week?
I was planning to kind of release them on a week-by-week basis. The reason I'm doing that, even though we ran this module a couple of times, I am, on my side anyway, I'm actually making some changes to the way I'm implementing the front end. I'm just using one or two other CSS kind of libraries, really, that I didn't use before. So I'm kind of holding off on that, and I was going to just publish them on a week-by-week basis.
Okay.
Yeah.
And same for the assignment. We have to wait until the end, or maybe in the next couple weeks.
My plan was to give a spec out around week, where I know 1, 2, 3, 4, maybe around 4-ish. But based on your question and the previous man's question, maybe I might try. I can bring that forward.
Okay.
I'll think about that.
That's fine. The only reason I'm asking is, because I'm doing those things for the last 10 years, so I can start work on the assessments.
Okay. I'm less worried about you, so yeah, I'll be using React Material UI. It's the Material UI framework that I'm bringing in that I hadn't used before. Prior to this year, I was using just Bootstrap, really.
Mhm.
And some of the client side, they're the two main ones, really. But have you played with React before?
Yes.
Yeah.
Yes.
Okay.
Actually, what I'm doing now on my current role is I'm building extensions for VS Code using React.
Okay. What I might, the only thing I might do is maybe publish the web app that we will be developing, so you can see what the end result will be after whatever 5 weeks. And I suppose I could push the code to GitHub, and you can just poke around with it and see what the end result will be. Yeah, I'll think about that as well.
Okay,
That's great.
Thank you.
Thanks. Anything else? Okay. I am now going to go back to the website, and according to the website, we need to maybe re-familiarize ourselves with JavaScript. And as I said a while ago, you may or may not have covered JavaScript. It may be quite a while since you looked at JavaScript. You are a experienced programmer, though, so we're taking those things into consideration. That's the way we are approaching it. So I'm just going to grab my JavaScript slides. Wow, that introduction took longer than I thought. I didn't realize there was an hour speaking. Okay, so I'm just going to give a very, 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 very quick background to JavaScript. It's kind of the waffly part, really. And then the way I'm approaching covering the language itself is to look at how we actually represent data or state in JavaScript. And it's all about this construct called an object, which isn't necessarily exactly like objects in the Java world. A lot of people may have Java experience where objects are all over the place, but objects in JavaScript are slightly different. And then I look at the behavioral logic representation in JavaScript, which is all around the notion of functions. This is kind of the marketing slide, or 1 or 2 marketing slides in terms of why is it a good idea to learn JavaScript. Well, this is a survey from GitHub. They do a survey. It's more kind of an analysis, really, I guess, of the various repositories on GitHub and how many of them are using what languages. And for a number of years now, JavaScript has been the dominant language from GitHub's point of view, in that there are more repositories that are JavaScript based than anything else. And that has been the case for quite a while. So it looks like it's a good idea to have JavaScript as one of your languages. This is a slide from Stack Overflow. They do a survey of what is being used out there in the community. And in particular, they ask a number of questions, but one of the questions they ask is what web framework. Now, they define a web framework in very general terms. Sorry, no, sorry, I beg your pardon. It's a different slide. They also survey people in terms of what language people are using in their job or for business or pleasure. Now, language has a very general definition, because you can see HTML and CSS there is classified as a language. But it's the same kind of message that we're getting. It seems that from this survey response anyway, and both of the slides now, this one and the previous one, are from just a couple of weeks ago, really. This also is telling us that JavaScript is a very popular language anyway. Now, when we think of languages, we often might think of them as being ancient, but in fact, the guy that designed the JavaScript language, a guy called Bernard Eich, is still a healthy living being. And he actually designed the language. I'm sure you've heard the story before. He essentially kind of designed the language over a very short period of time, like maybe a 2-week period, I think, although it varies. Some people say it was a long weekend. Some people would say it's a 2-week period. But either way, it was a phenomenal effort that he actually designed the language over a very short period of time. He worked with a company called Netscape, as you may have heard, one of the first companies to give us a browser. And this is back in the early 90s. Now, he was influenced by those 3 languages there, Java, Self, and Scheme. You definitely heard of Java. Java was very popular at the time. This is around the early 90s. In fact, that's why JavaScript is called JavaScript, even though from a technical point of view, it's quite different from Java. Java and JavaScript are quite different, but it was named JavaScript in order to kind of catch people's eye. The other 2 languages there, Self and Scheme. You may not have heard of Self. It never really emerged as a well-used language. Self is also an object-oriented language, just as Java is an object-oriented language in the sense that it's class-based. Scheme is what's called a functional programming language, and JavaScript is influenced by the whole functional programming space as well. Now, I don't want to dwell on this slide too much now because it's a bit waffly really, but the only thing I want to get across is, if you haven't kind of done anything in the JavaScript space before, is to be aware of what's called ECMAScript. What happened, as I'm saying in the slide there, just 1 second now, is Netscape essentially handed the JavaScript language over to an organization called the ECMA organization, European Computer Manufacturing Association. And what ECMA does, it's just a body of interested people that are interested in the computing space, and they define standards in the computing industry. It's a non-for-profit organization. They handed the JavaScript language over to the ECMA organization, and what they did was they essentially abstracted from the language and came up with a specification for it. And that specification then is the standard by which the language aligns itself with. So strictly speaking, ECMAScript, and sorry, they called that specification that they drafted for the language, they called the specification the ECMAScript specification, which I'm mentioning here. So technically, ECMAScript is a specification for a programming language. The only implementation of that ECMAScript specification is JavaScript, and that isn't going to change, unlikely. So that's the relationship between ECMAScript and JavaScript. So ECMAScript is the specification for the language, and ECMAScript, you can see here, I'm saying the first release of the ECMAScript specification, ES1 there stands for ECMAScript 1. The first release was in 1997, and the top of the slide, I'm saying that Brendan Eich, designed the language initially back in the early 90s. So a number of years before they handed it over to the ECMA organization. They released the first specification for this language in June 97. And each year after that, then they kind of upgraded the specification. Now you can see here, ES4 was essentially abandoned. And ES4, we're talking about kind of 2000 now, I suppose. And for a while, it was felt that the ECMAScript stroke JavaScript was actually going to die, that, you know, the language wasn't really going to be used because it's the only place you could run it, as I said, was within the browser, which was fairly limited. But lo and behold, this Node platform came along around 2009. And as I've already mentioned, Node allows us to write JavaScript on the server side. And that really put new life into the JavaScript language. And it has since flourished since then. So it's thanks to Node that JavaScript is the #1 language on those 2 surveys that I showed you earlier on. And so there's a big gap now. We're talking about 2009 now, as opposed to ES4 was back around 2000. As I said, the language almost died in that intervening period. But in 2009, the ECMA organization released a new specification or upgrade to the specification, which we call ES5. So this ES5 standard is a kind of a landmark in one sense. And it's a kind of it's a reference point for the language. So you hear every now and again you hear me referencing ES5. So ES5 is the version of JavaScript that is aligned with the ES5 ECMAScript 5 specification. Now, a lot happened between 2009 and 2000 in terms of other languages coming on stream, and those other languages having features that the JavaScript language did not have. And so ES6 is another kind of landmark in the ECMAScript series of specifications. And what ES6 did was added features, mainly through pressure from the community, really, added features to the language which other languages had at this stage, but JavaScript didn't. In particular, for example, classes. The JavaScript language does not have classes within its foundations, but the ES6 standard and subsequently the JavaScript language actually brought classes into its syntax. Even though at its foundations, it doesn't have a class model at all, as Java does. So the classes that you actually use in your JavaScript code, if you do write JavaScript code and you're using classes, they actually get converted back into functions, as it turns out. And from ES6 onwards then, so ES6 was 2015, and it's often referred to as ES 2015. And for each year from then on, there has been a new upgrade to the ECMAScript specification and new features added to the language. And the features really are what we often refer to as syntactic sugar. It's just trying to make the syntax of the language a little bit easier from a developer experience point of view. We'll probably be really aligning ourselves with ES6, but I will be introducing other syntactic sugar that was introduced in subsequent specifications as well, every now and again, as we work our way through this module. So ES6 and ES5 are 2 significant releases. And I'm only mentioning this guy here, Douglas Crockford. He's kind of one of these rock stars in the JavaScript world. If you ever Google Douglas Crockford on YouTube, you'll get some really good presentations that he does on the JavaScript language. And he looks really at the internals of the language itself, which are always very interesting, and he's kind of entertaining as well, because the language internally is quite different from what you see as a developer. I suppose as most languages do, but certainly JavaScript does, because as I said there at the beginning, it's even though it may seem like a language a bit like Java, it has a lot of differences to Java internally. Now, so JavaScript began life back in 2009, and we're now 2021. But kind of browsers have been around for a long time as well. And it's possible, and okay, browsers are evolving, and they're kind of trying to evolve with the language, but they're lagging the evolution of the JavaScript language. So you can't necessarily write really, really modern JavaScript code and expected to run in every browser that's out there. And certainly the older browsers can't process the newer syntax of the JavaScript language. So what do? Do we just not worry about that and only write our JavaScript that can run in modern browsers? That wouldn't be a good idea, because that limits then the reach of any JavaScript code that we write, any web apps that we write. So really what we need to do is we need to convert the JavaScript that we write, which is presumably ES6 or newer, and convert it back into a version of the language which we can be fairly sure all browsers can execute. If I might go back to the previous screen, essentially what we want to do is we want to send JavaScript down to the browser that is ES5 compliant, because we're pretty certain that all browsers that are being used out there in the globe can actually execute raw ES5. So if we write ES6 or ES7 or whatever JavaScript, we need to convert it back to ES5. That process is referred to as transpilation. And fortunately, there is a tool, and really it's only one tool, which is the dominant one, which is the Babel tool that will do that for us. I'm just mentioning it here because it'll be something that exists in the background. We won't be using it kind of from the command line. We won't have to transpile our code directly ourselves. The developer tools that we will be using will have Babel built into it. So Babel and transpilation are part of the whole, the background of what developers will be using in the JavaScript world. That's my background. Let's talk about the actual language itself. And as I said, I want to cover the language from a data representation or from a state perspective, and also then from a behavior or logic perspective. So obviously any language, any programs that we write, we're going to be representing data, and really any languages that you have looked at. When we talk about data, there are essentially two data types. There's primitive data and complex data. Primitive data is really the same for all languages. So the primitive data types of JavaScript are the same as any other language you've looked at. So we want to be able to represent numbers, strings, booleans. We have the null type, which is quite similar to null in Java. And then we've got this odd one called undefined. And I suspect undefined is a primitive value that originates back to the very beginning of the JavaScript language, which, as I said, was designed over a very short period of time. And it can be a source of a lot of errors and a lot of frustration, as I'm sure you're going to find as you work your way through this, because you're going to hit it every now and again, and mainly in the context of getting errors. But there is a value called the undefined value, which a primitive data variable might have as its current value. And in the second line there, I'm saying undefined is a variable with no defined value. So essentially, if you declare a variable and you don't assign anything to it, then by default, its value will be the undefined value. It's badly named, but as I said, it probably relates back to the origins of the language. I'll come back to that later on, actually, in this set of slides, and for sure you will come across it, as I said, in the context of debugging as well. So we have primitive types, and then for any other type of data that you want to represent in your JavaScript code, we use a construct called an object. And I'll talk about those a little bit in a little while. I'm just mentioning here as well that JavaScript is a dynamically typed language. What that means is that you can declare a variable in JavaScript and assign it, let's say, a number. But then in the very next line, you can reassign a string to that same variable. Probably wouldn't be a great idea, but from the language's point of view, you can. So a JavaScript variable can be assigned a different value, a type of value, dynamically at runtime. Hence, we say it's dynamically typed. Unlike Java, for example, when you declare a variable in Java, you have to state at the outset, what type of variable is it? What type of value can it hold? With JavaScript, you don't need to do that. And that can give you great flexibility in one sense, but it can also be a source of errors in another sense. So a lot of people don't like this dynamic typing that is built into Java. If you've heard of TypeScript, you may be aware of TypeScript. TypeScript is a new language from Microsoft, really, which essentially tries to merge the data typing, the static data typing that you get in Java, and bring that into the JavaScript language. We won't be looking at TypeScript though. Now, as I said, I am kind of assuming that you're all beginners here, even though you may not be from a JavaScript point of view. So I have to start from the ground up. What I'm showing you in this slide here is a screenshot from VS Code. Maybe I should open up VS Code at this stage. And what I'm going to be doing is just stepping through some little simple JavaScript files that will be demonstrating various aspects of JavaScript objects and primitives, even though there's only one file on primitives, because primitives are fairly straightforward, really. But what you need to do in order to run these samples that I'm going to be stepping through today and the next day as well, will require you to add an extension to your VS Code implementation. And so if I just flip over to VS Code.
Sorry, can I ask a quick question?
Sure.
This VS Code tool editor, can you run Node and front side or normal JavaScript in there?
Absolutely, yeah. It's just a text editor. I mean, you can do Python development, Java development. It's not tied to JavaScript at all, actually, unlike kind of WebStorm, which, as far as I'm aware, is more tied to it.
But you can actually run the code without having to leave that program.
You can run the code. Just if I let me just show you. So this is what you see initially, I think, when you will start up VS Code. And if I just pull in. So this folder here, actually, you will get in this week's lab. And you can just drag it over into here. Okay, so you can see I've got some JavaScript files and I've got a HTML as well, which is not very significant. Now, to answer your question, what you can do in VS Code is you can open up what it calls an integrated terminal, but essentially, I just collapse these here. What you have here now is a terminal session, and it's currently aligned to the folder that you're looking at, or the project that you've loaded into your VS Code area. So you can type any kind of normal commands here, like cd. You can type node. If you have node installed, you install node separately, but you would go node. But let's do it. Yeah, so it's just ran this file, and there's nothing terribly interesting in the file, but it's just ran that JavaScript. Does that answer your question?
Yeah.
So that's what's nice about it, really, I find, is that you never have to leave, hardly ever have to leave the VS Code environment when you're doing your development. Any command line stuff you do, you can do from here. So you'll be doing, for me anyway, you'll be submitting your Git commands here, even though VS Code's Git integration is really, really good. This is what we call the activity area here. You can see I currently have the, I think it calls it the Explorer kind of activity. So that's what you would be, that's the activity you would be mainly in, where you see your files, and whatever file you click on, you see over here in the editing area. I'm just going to pull this down a little bit. If you want to do some Git related stuff, here, what this is telling me here now is there is a Git repository actually as part of this project. It's telling me that I haven't changed any files, but if I do make a change to a file, that and save it. Okay, it's now telling me from a Git point of view, this is a modified, this file has been modified since you did your last commit. It's really, really nice. I think you'll find if you haven't used VS Code before, you're going to find it a really nice experience. Just going to undo that. So where are we now? So I've started up VS Code and I have loaded up or imported, I suppose, a particular folder, this folder here. And as I said, you will get this folder, this specific folder with this week's lab. Just going to flip over to, I'm jumping around the place now, I appreciate, but if I go into this card here on the website, we're currently looking at these slides here. I have 2 labs here. I don't expect you to do both of the labs this week. In fact, given the way timing is going with me here now, we may not even get enough covered, because again, I am assuming that you either haven't done JavaScript or you haven't done it for quite a while. I'm going to continue on making that assumption, even though that might frustrate some of you initially, but that's okay. I can cope with that. But this is this week's lab, and if you click into it, then there's a whole series of steps that you walk your way through. And the very first one, it tells you to, well, this is telling you to install an extension, which I'll come on to in a second. And here then you're told to, where do I do the download? Somewhere here I mentioned where you can download the code. There's a hyperlink. I've forgotten where exactly it is, but you click on the hyperlink and you download a zip file. And when you unzip it, what you will get is this folder. And you just pull that into your VS Code as I did a while ago, and you work your way from there. And I step you through various kind of little exercises that I want you to do. But it assumes that we get through the slides, which, as I said, we may not. That's okay if we don't. I'm going to go back again to VS Code. So VS Code is lightweight initially, and that's a good thing. So it's very quick to download, very quick to install. It's just an unzip really. But there are loads and loads of extensions that you can add onto to your VS Code. And as well, the whole extension installation is foolproof as well. But to find extensions or to install an extension, you click on this extensions activity here. And what you do then is you type in a part of the name of the extension that you want to install. So you found some extension that you really like to install on your VS Code installation. And so you just type part of the name and it will dynamically show you what matches. All of these extensions reside on some remote repository that VS Code knows about. So it's checking with that repository for matching extensions. Now, there's one that I'd like you to install for this particular lecture, and it's the one called Live Server. So if you just start typing, you can see it's filtering the matches for me. Now, the one I'm actually interested in is this one. Other ones that are matching are these ones here. And if you want to install one of them, you just click the install button and let it do its thing. You really don't have to do anything other than that. It downloads it and adds it to your VS Code installation. In most cases, that's it. In some cases, it's probably a good idea anyway, just to restart your VS Code once you've installed something new. So I've already installed this one. This one here, which is why I don't have an install button. And this is the one that I'd actually like you to install for the purpose of this week's lab, and in fact, the second lab as well, as it turns out. And that's what I think I stepped you to that in the lab anyway. I explained that again to you in the lab. So if you didn't fully follow that, don't worry about it. And that's also what I'm kind of outlining in this slide here. I'd like you to install the live server. Essentially what it is it's a web server and it supports live reloading. When you install this live server, if you want to start the server, I'm showing you how you do it down here. What you'll see is, if you can see there, there's a little link down in the status bar called Go Live. And if you click on that, that'll start up a web server, and it'll serve the it will serve the contents of the project that you currently have opened or imported into VS Code. So in my case, I have currently loaded this project into my VS Code, and if I start, and you notice there's only one HTML file, and so when I start my server, let's do it actually. It kicks up a browser, opens up a new browser tab, and it displays, in my case, the contents of index.html. If there was no index.html, then it would just show me the contents of the actual folder itself. It would show me these individual files. In my case, it's showing me this one, and there's actually very little in my index.html. Let me just collapse this here. That's all that's in my index.html. So JS demo, that's what we're seeing in the browser tab. JS data and nothing else. I'm not really interested in the HTML side of this. What I'm really interested in is in JavaScript. And just as I'm on it, so here I'm using the Chrome browser. I'll be using the Chrome browser throughout this module, and Frank as well. And the Chrome browser and all browsers, as you may know, have a lot of developer tools added onto them. They've become really, really sophisticated in recent years. Now, when you open up the Chrome browser, get used to actually opening up what its developer tools as well. And how you do that, and again, I think I explained this in the lab, but how you do that is you select this here in the top right, click on more tools, developer tools. And this will become your best friend really after a while. It may need the context of kind of debugging as it turns out, but you've been a number of panels here available to you. For now, all we're interested in is the console panel. And in the console panel, it will, if you happen to have some JavaScript code running behind this page or in association with this page, if you have some JavaScript code and that JavaScript code tries to output something to the terminal, then you will actually see it appearing here, as we'll see in a second, I guess. So just get used to, as I said, always nearly opening up the developer tools throughout this module, really, to help you with debugging. Right, where are we? That's what you need to set up for working your way through the first lab. Okay, so back to primitives, data primitives in JavaScript. So to illustrate them, because we do have to start from the beginning, I've just put together a simple little JavaScript file. So what I'm showing you here is a simple JavaScript file that's demonstrating to us how we declare primitives. It also demonstrates how you output something to the terminal using console.log. And that's all that's being demonstrated here, so it's pretty simple. I'm also showing you an index.html file, and you can see that it has a script tag that is referencing my JavaScript. So when this index.html gets loaded by my web server, because it has a script tag referring to some JavaScript code, that JavaScript code is also going to be loaded into the browser, and it's going to execute. And fortunately, our JavaScript is doing some console.logs, so we'll be able to see the output produced by these console.logs in the developer tool console that I just showed you there. And that's what I'm showing you on the right. Okay, so let's do that, even though I've kind of already done it, or have I? Maybe I haven't really. So here's my index. My live server is now running, and it's showing me this web page. And in the web page, I do have a number of script tags, but right now they're actually commented out. So if I start from the top and work my way down, and I'll uncomment this. Now, when I save, if I flip over to the browser now, nothing has happened so far in the browser. In particular, there's nothing has happened here in the developer tools. But once I save the change that I've just made, which is to uncomment this line, what the live server will do is it will push all of the updated HTML and JavaScript down to the browser for me. It'll do what we call live reloading. So you don't have to do any kind of manual refreshing. So I hit my save on the file. I'm just using keyboard shortcuts here now, but as a beginner, you might do the usual kind of file save kind of stuff. But yeah, it's probably a good idea to learn a few of the keyboard shortcuts just to make life a little bit easier for you, for yourself. So I'll save it. And if I flip over to the browser, then some new stuff has appeared here. And this stuff has been generated by my JavaScript code. And let's look at the JavaScript code now, which is really what we're interested in. So the file that I am referring to is 01 primitives. Here's my 01 primitives. And the purpose of this is just to demonstrate how you declare primitive variables. Let's just quickly run down through it. So I'm declaring a variable called foo1. So let is a keyword in JavaScript, which we use when we want to declare a variable. In the early days of JavaScript, let is actually a keyword that was introduced by ES6. Prior to then, the keyword was var, but var is now kind of redundant, really. So I'm just declaring a primitive here, and I'm assigning it a numeric value. I'm declaring another primitive, I'm assigning it a string, I'm declaring another primitive, assigning it a Boolean. So true is obviously a token, a valid token in the JavaScript language. I'm declaring another one, assigning it null. Now, another feature that was introduced into JavaScript in ES6, I think, is the keyword const. So I'm actually declaring a primitive here as well, or I'm declaring a variable really, and assigning it a primitive value. So you might ask yourself the question, what's the difference between const and let? And it's subtle, but it's kind of important, and it's mainly to help the reader. When you declare something with let, essentially what you're telling the person that's reading your code is this variable may be reassigned a different value somewhere later on in the code. When you declare const, you're saying that this variable cannot be and will not be reassigned a different value. There is a bit of a gotcha with const, which I'll talk about later on. I don't want to talk about it now, but that's the essential difference. You're declaring a constant versus something whose value can vary over time. And then I'm doing a console.log, mainly just to help myself understand what's going on, even though there is not a lot going on. And console.log, I'm using string concatenation here, which is kind of ugly. And in fact, string concatenation is not really what we would do anymore. But in the early days of JavaScript, that's the only way you could output. If you want to output a number of variables in one go, you'd have to use this kind of string concatenation style. But ES6 or 7, I'm not sure which, introduced something called string templating, which is a lot nicer to use. We'll see that later on. So this console.log of foo1, foo2, etc., that's what's generating. That's what's generating this here. Yeah. Later on in the same file, I'm reassigning a different value to foo1. Okay, you don't use the let keyword here. If I use the let keyword here, then that's going to cause an error because I'm essentially trying to declare another variable that has the same name as a variable that's already been declared. So that might be a beginner's mistake, maybe to use let. I have to find out how to get rid of these indentation alignments. They're kind of annoying. But so I'm reassigning a different value to foo1. That's okay. The only reason I'm showing you this here is foo2, I'm assigning it a numeric value, but at the beginning, when I declared foo2, I assigned it a string. And this is this notion of dynamic typing. So the type of the value that you assign to a variable, its type can change dynamically at runtime, and the runtime doesn't complain about that. It certainly would in Java, in the Java language. So that's just a very simple illustration of dynamic typing. Other than that, there's nothing else interesting going on in that line, really. Here, I'm declaring a new variable foo5, but I'm not assigning it any value. And the reason I did that is, if I do now a console.log of foo5, I get our friend undefined. Yeah, so undefined is an actual, it's an actual value kind of technically, even though that kind of confuses people. It kind of suggests from the name, and it suggests that something has not been defined, but clearly I have just declared foo5, it has been defined, but it hasn't been initialized. That's the key thing, really. Undefined is assigned to a variable if you do not initialize it. We're doing our initialization here. We're not doing any initialization here. And that's it. What's the purpose of this line here? I've commented it out. If I uncomment that, note pi there, I've declared as a const. If I uncomment it and save it, then I get an error, and the error is essentially telling me you cannot reassign a value to a variable that has been declared as const. You can reassign lets, but you can't reassign const. And really the only purpose of const is to make it, is to benefit the person that's reading your code. A const tells the reader of your code straight away something about the nature of the variable, i.e. it cannot be, it will not be and cannot be reassigned a different value later on. So let's undo that and save it again. Back to my browser, and it's now corrected itself. Any questions about that? Right, let's move on to so primitive types. Okay, let is a keyword. The colon, I'll come on to the colon in a second. In terms of giving names to variable or identifiers to variables, there are a couple of basic rules. None of them are surprising. You can't have a space in a variable name. You can't begin a variable name, or you cannot use an identifier that begins with a numeric character. And there are some other ones as well that I'm not going to get into, but it's all the kind of usual stuff. The same operators that you're familiar with from other languages, the arithmetic operators, subscript operators, etc., etc., etc. The semicolon, as it turns out, is optional in the language. We're familiar with semicolons maybe from other languages. In most languages, excuse me, the purpose of the semicolon is to indicate where a statement ends, a statement terminator. Now, it turns out in JavaScript, it's kind of optional. You can leave it out in most cases. Although, interestingly, if you write ES6 plus code and then you use the Babel tool to transpile your code back to ES5, Babel will perform what's called automatic semicolon insertion, ASI. So it puts the semicolons into your JavaScript code anyway for you, which is kind of nice, really, so that it makes it easier, I guess, for the runtime to determine where a statement ends, because of course statements may be multi-lined. But essentially, sometimes I use a semicolon, sometimes I don't. It's just a matter of whether what mood I'm in. There are a few minor edge kind of cases where it's probably a good idea to put the semicolon. That's all I'm mentioning here. I'm not going to get into examples of where it might cause problems if you do not use a semicolon, and it's particularly in relation to multi-line statements. If a statement spans multiple lines, then it may be of benefit to the runtime to put the semicolon where the statement actually ends, so that the runtime doesn't get confused. But for sure, that's not going to happen in any code that you write. unless you are an extremely sophisticated JavaScript programmer, which you may be. Now, I'm talked a little bit there about let and const, and let's just reinforce it. So let is for declaring variables that can be reassigned. Const is for declaring variables that cannot be reassigned. So that makes sense. I suppose we understand what's being said there. Const is obviously short for constant, and constant is something that doesn't change. So yeah, it makes sense that a constant shouldn't be reassigned a different value. And it's mainly, as I said, for the purpose of the reader. I mean, you could be lazy, as I often am, and just declare everything with let, even though I might know that certain variables that I'm declaring with let aren't going to be reassigned. So it's just laziness on my part not to have used const instead, because it would give a clearer intent to the reader of my code. The other thing about the difference between let and const is, you saw there in the sample code that I looked at, I declared the variable foo5 and I did not initialize it. That's fine. You cannot declare a const without initializing it on the same line. Put another way, you have to initialize a const when you declare it. The last point I'm making on this slide is that both, whether you declare a variable as with let or with const, those variables have what we call block scope, which is essentially the same as Java. A block of code in JavaScript is any code that's enclosed in curly braces. We haven't seen anything so far, but we'll be using curly braces, for example, if we're using for loops or if statements. When we're declaring a function, we close the function scope using curly braces. So for example, and if you declare a variable inside a function, then because that function has curly braces wrapping the beginning and end of the function, those variables are only accessible within the function. So this is the idea of block scoping. Similarly, if you have an if statement and you declare a variable inside the true part of the if statement, in JavaScript, you have to wrap the true body within curly braces. That becomes a block. So if you declare a variable inside that block, it's only accessible inside the block. So it's the usual kind of stuff, as I said, you're probably familiar with already. And I suppose the other reason I'm mentioning block scope is that prior to ES6, JavaScript did not have block scoping. So in the earlier days, ES5, which is really only from kind of 2015 backwards, the scoping was quite different. The scoping rules were quite different. We don't need to go into them because we're not going to be writing that kind of code anyway. So that's primitives, and there's no surprises there really. The more interesting part of data representation in JavaScript is the notion of an object. And I'm saying an object here it's a fundamental structure. So it's been part of the language from day one. And it's the structure that we use for describing or for coding any kind of complex data. It's a unit of composition for data or state. And syntactically, this is how you declare an object. So the curly braces actually are used for a number of different things. I mentioned curly braces there on the previous slide in relation to variable scoping, but the use of curly braces here hasn't really got to do with variable scoping. It's just we use the curly brace to delineate the beginning and end of an object declaration. So an object is a set of key value pairs. So we have a key, a value associated with that key. We separate the key and value with the colon symbol. And then we can have any number of key value pairs making up an object, where each key value pair is separated by a comma. A key value pair is referred to as a property. So in this generic kind of example here, this is one property in my object. This is another property in my object, and so on. If we skip down to the bottom of the slide, here I'm declaring using const, as it turns out. I could have used let as well. There is a difference though, and I'll come back to that in a while. But I'm declaring a variable called me, and it's got a key with the name first name, and the value associated with that key is a string called Diarmid. I've got another key called last name, and the value associated with that happens to be a string as well. The types of the values don't all have to be the same. So this is an object that has two properties, two key value pair sets. Okay, so key value properties, they're all terms that we use in relation to objects. And as you'll see later on, the value associated with a key could actually be another object. So you could have objects nested inside objects, and that's really going to be a common pattern that we're going to see throughout this module. So you need to be comfortable with that idea, but that'll come in time, I guess. So when we declare an object, then presumably somewhere in our code, we want to be able to manipulate that object. And by manipulate, we mean maybe we want to access the value associated with a particular key to do whatever with it, to display it or to process it in some way. And secondly, by manipulating, we may want to change the value associated with a key. That's what I mean by manipulation in this slide. And there are two notations that we can use to do this. Again, this was part of the language from day one, and they have remained so. So the two notations are referred to as the dot notation and the subscript notation. So the examples are obviously better to. So if you see this example here, the way you use the dot notation is you use the object name or the object identifier, I suppose, followed by the dot, followed by a particular key within that object structure. So this entire expression, in my case anyway, according to the previous slide, this entire expression is going to evaluate to the value associated with that key in this object, which in my case was the string Diarmuid. The subscript notation uses our subscript square bracket symbols. And what you need to remember is that in this case, this is the key, but you have to enclose the key in quotes. So the key has to be a string when you're using the subscript notation. That might be a beginner's mistake. Again, if you drop the quotes there, you're going to get a runtime error. And again, that expression is going to evaluate to, in my case, the string Diarmuid. And you can mix and match these. You can mix and match the dot notation and subscript notation as much as you want to. I'm saying here it's the same notation that you use if you want to change a particular value within an object. So it looks like what I'm doing here is I'm changing the value associated with this key in this object. So it's a standard kind of assignment statement, and I'm making that change. Same here, you can use the subscript notation using if you want to change a property value. Subscript notation supports variables. So if we again let's look at the example. I have a variable here, which I maybe shouldn't have, but I've called the variable key. It's assigned a string, and then I'm using that variable over here, right over here. Yeah. I just happen to be using it in console.log. So this is the subscript notation, but this part of the subscript expression is actually referring to the variable on the left. I'm not enclosing this in quotes. If you put quotes around that there, what do you think you would get? If I put quotes around key there, then the runtime is going to look inside the me object, and it's going to look for an existing property that has the key called KEY. And according to my previous slide, there isn't a property in the me object that has a key with the name KEY. So that entire expression is actually going to evaluate to our friend undefined. I didn't want to come across that and make that comment at this early, but either way, obviously it would be an error. Like it's not what you meant. If you put quotes around key there, clearly what you meant to do was not have quotes around it. You actually want the runtime to evaluate this variable, And by evaluate, I mean substitute the variable with its actual value. Its actual value is the string last name. And then this expression will be right. Then this expression is going to generate O'Connor. Next, objects declared with const. Oh yeah, this is the gotcha with const. What am I saying? I'm saying objects declared with const are mutable. Mutable means that the internals of the object can change. Now that kind of contradicts what I said about const earlier on. I said that if you declare a variable with const, you cannot reassign it a new value. However, if you are assigning an object to a const, you can actually make changes to the internals of the object. What you cannot do is assign a completely new object to that const variable. And as I said, that is a bit of a gotcha initially. So there it is anyway, and I think we'll see an example of it in a second. So const cannot be reassigned, but its internal value can be changed. Samples, we're told to look at sample 02, so let's do that. So this is the way you play with the samples. Now we're back to here. I now want to look at the code in here, and I actually want to activate it, I suppose. Let's go back into the index.html. I'm going to comment this line out. And uncomment this bit. Let's try that again. So I'm now bringing in 02 objects.js, which is this guy. Just want to leave that open for a second. And once I save the change to index.html, which I haven't done yet, on doing the save, now the browser will have been refreshed with the new. And so this is now being generated by the 02 JavaScript file. Let's look at what's happening inside in the 02 JavaScript file. And it's just demonstrating some basic object syntax to us. So here I'm declaring an object. Again, I've used the me object with some untrue facts about me, like I am not 21 years old. I do not have that amount of money in my bank. That's true, but the rest, anyway, that's the running joke every year, and it never works, but there you go. So here's an object with some key value pairs, that's fine. And I'm just demonstrating then the dot and subscript notation. So in this line here, I'm console.log me.name plus lives at me subscript address. So that line there generates this bit here. All I'm demonstrating here is I'm declaring a variable and assigning it a string, and then I'm using that variable down here. Okay, so I talked about that a while ago. Moving on, I'm just changing a particular property. So me.address is going to change, and when I do a console.log now, I get 2 Main Street as being the address, hopefully. Yep, 2. So far so good. All fairly basic stuff, admittedly. So apologies if this is too basic for you. Back to the slides. That's manipulating objects, dot notation and subscript notation. Objects are dynamic. What that means is that you can, at runtime, you can add new properties to an object or remove properties for an object at runtime, as opposed to at coding time. And we have examples of that in the 03 file. So again, I'm jumping around a little bit now, but I don't want to bore you either with this stuff. Back to my index.html and uncomment this and bring in this. Save it. What's going on inside in 03? 03. Again, I've got the me object, and see here where I'm going me.employer. That is so annoying, that stuff keeps popping up. Me.employer, like if you look at the object at the top there, I don't have a property called employer. So this expression on line 10, the effect of that expression is to dynamically add a new property to the me object where the key is employer and the value is WIT. That's what I mean by dynamically adding properties to an object. That happens at runtime. Down here, I'm showing you, and the syntax is slightly out of sync with everything that we've seen so far. This is how you actually delete a property from an object. So there's this keyword delete. So that's going to remove the age property. And so when I do a console.log of me.age, and this is really where I want to just make you aware of this. When I do a console.log of me.age, what I actually get, as you may have already seen, is I get the undefined value. Now that doesn't cause any problems for us. It doesn't. You might think that that expression me.age would cause my program to crash or to throw an exception. JavaScript has exceptions, by the way. We'll see examples of them later on. But it doesn't. It's kind of silent when it comes across this. When it comes across a property, trying to refer to a property that doesn't exist in an object, because I've just removed it here, and believe me, it has been removed. The runtime is silent about the fact that it's not there. What might cause problems, though, is if you start trying to manipulate age, thinking that it does actually have a meaningful value other than undefined, and that can be an issue, which I think I mentioned in a few moments, in a few slides down the line. But for now, when you try to access or reference, when you try to reference a property that does not exist in an object, the expression will just return the value undefined, and you won't get a runtime error. Objects can be nested, so the value associated with a key within an object, the value could be an object in itself, and we have examples of that in the file 041. Let's look at 041. And you see here where the name property within me, the value that I've assigned to name is actually an inner object. And so this is where you might get tripped up in terms of the syntax. So the value assigned to name is this entire expression here. And things you might do is you might forget the comma there, because each key value pair has to be separated by a comma. You know, we've got a comma here, and so on. So don't forget the comma there. But for now anyway, all I'm illustrating here is the idea that the value of a property could itself be an object. And that can go on and on and on. So you can have any levels of nesting, as we refer to, that you want to. Similarly, I've got a nested object here, but for now, the nested object only has key value pairs where the values are primitives. And when you've got this kind of nesting, then what can also trip you up is when you're trying to navigate down into the inner objects or into the nested objects. But just remember the first principles of the dot notation and the subscript notation. So for example, here, this expression here, me.name, that expression me.name, that evaluates to this object here. And if that is the case, then when I when I tag on the subscript bit, it makes sense. So the subscript part here is subscripting relative to this object that I've highlighted. And the object that I've highlighted does have a key called first. So that entire expression evaluates to Diarmid. And you can mix and match these as much as you want to. Over here, I'm using the subscript notation first for no particular reason. So I'm me subscripting into finances. So again, this expression is going to evaluate to this object. And if that's the case, then having using the subscript again here makes sense, because the object that I've highlighted there does have a key called bank. Instead of doing it that way, I could have done it like this. I could have used the dot notation. Dot bank. I didn't misspell it. Sorry, get rid of that's not good. Dot. So again, as a beginner, maybe those kind of things might throw you a little bit, but just remember the first principles of the dot notation and the subscript notation, and you'll get familiar with it after a while. So you can mix and match them as much as you want. Sometimes you don't have a choice. Sometimes you have to use the subscript notation, but in most cases, it's completely a matter of style. I would imagine in most cases, any kind of JavaScript code that you read from other people, the dot notation is by far and away the most commonly used one. But in certain cases, you have no choice but to use the subscript notation. So that's nested objects. I'm not going to show you what it outputs to the screen. You can do that yourselves. Moving on. O42, you can look at very quickly. O42 is this one. And really all that's happening here is in the me object here, I've got a key called name and the value is name. There's no quotes around it or anything. So this name here is referring to a variable that is declared elsewhere. And of course it's declared there above at the very top. So it just simply substitutes this object, if you like, is replaced by that name, and it just works as before. And the indexing and the subscripting and the dot notation works the same as before. The only comment, the comment here is, and this is something that was introduced in one of the newer versions of the ECMAScript language. If you've got a case where the key and the value are the exact same, then you can actually just rewrite it like that. Okay, you can actually get rid of this. And it's going to be interpreted as you are declaring a property within the me object where the name or where the key is name and the value is some other variable that you have declared elsewhere, some other variable that has the name. I should have come up with different labels for these things. But it's a shorthand, as I said, that more experienced kind of JavaScript programmers, you might see it every now and again, and it might throw you a little bit, the syntax, because it looks a bit odd, like it looks like I'm declaring something, but it's not a key value pair. But in fact, it does get expanded out into a key value pair at runtime by following the rules that I just mentioned there. Other than that, there's nothing else new in 0.4.2. And again, what you should do yourself really is to work your way down through these, commenting out and uncommenting them one by one, saving the file and checking to see what they actually display in the browser's console, just to make sure that you're comfortable. And of course, as well, maybe play around with the code a little bit, save the changes that you make to the code, see that you're getting in the browser's console what you expect to see. No doubt at some stage you're going to get a syntax error, and you just have to correct the syntax and save it and move on like that. So again, if you haven't been doing any JavaScript for quite a while, or you're a beginner, that's really what you should be doing in the coming week. I just thrown together some other odds and ends as well related to objects. I'll leave it at this slide now because I haven't taken a break, I know, and I'm running on quite a bit. I'm checking my clock here beside me. There are just some odds and ends that I've just tagged on to our discussion on objects. I think maybe because we use them every now and again, or we might use them once or twice later on down the line. Like there may be cases in your code where you have an object, maybe you write a function that receives an object and you want to just get all of the keys from that object and put them into an array as an array of strings. And so you can do that using this statement here. Equally, you may have a case where you've got an object and you just want to extract the values and put the values into an array. The values could be of mixed type, but this expression here allows you to do it. There's also a token introduced in more recent versions of ECMAScript, the in operator. The in operator allows you to write expressions like this, which you might write in an if statement, where you're essentially what you're doing here is you're checking to see, does this object contain a key named name? So this expression here is going to evaluate to true or false. And then you do something if it's true, something else if it's false, I guess. So it's a nice way of expressing whether an object has a particular property or not. I have examples of all of these in 042 nested objects, and I'll leave it at this now because I know I've gone on for quite a while. 042. Is that the right one? So I've got the me object, the name object. That doesn't look right. Am I looking at the right file? Oh yeah, okay. So you can see it here, right? Object that keys me. Okay, technically, object is a global. It's a global object. Keys is a method associated with that global object. Strictly speaking, it's a function, and this you can pass to that function stroke method. You can pass it an object, and what it returns back is an array, and the array will contain an array of strings where the strings correspond to the keys in this case, in the me object. So when you do a console.log of that, you'll see it anyway yourselves, what it returns back. Console.log. This is demonstrating getting the values. You can just uncomment that and see what it produces for you. Here I'm using the in operator. So this expression is going to evaluate to true because the me object does have an address, whereas this expression here is going to evaluate to Boolean false. Okay, I have gone on for long enough. I think hopefully I didn't ram through that too quickly. If I just check to see now, sorry, how far have I got in the slides? Yeah, I've actually gone as far as I would have hoped to have gone, which is great for me, maybe not for you, but I'm recording this, so I'll put it up on YouTube later on if you need to review it. You are now, hopefully anyway, in a position to work your way through this lab. This one here. You certainly are not in a position to work your way through this lab unless you've got some JavaScript experience already, and you can certainly have a poke around with it. Okay, hopefully I didn't run through that stuff too quickly now, Richie, but anyway, and still my camera isn't working, so I'm going to leave it at that. I'm going to give you a chance, maybe just in case there are any remaining questions or last minute questions that you might have for me. You're still there, are you?
Yeah.
Okay, no problem. We'll leave it at that. So, and I think Frank is actually on next week. He's just going to be giving you a refresher on the other two foundations of the web, which is HTML and CSS. So that should be a little bit easier, I think. Then I'll come back the following week and I will complete this set of slides that I'm looking that I've started today. I knew I had no intention of completing the set of slides that I've just gone my way through. I knew that wasn't going to happen, but I just put them there anyway. And when I come back to you, we will start looking at functions, which is kind of the interesting side of JavaScript, I think.
And can I ask a quick question?
Sure, by all means.
So when I learned JavaScript a long time ago, and now all these new things have come out, like these kind of shortcuts,
yeah,
arrows and things like that. Do you go into that?
Oh yeah, that's all on the functional side. So we look at arrow functions. Well, anonymous functions have been there from day one, but a lot of the syntax that we will be writing will be using arrow functions for sure.
Okay, because that's the kind of new stuff I get lost with anyway.
Yeah,
okay.
What you won't see is you won't see the this variable appearing in any of my code, and really that's why kind of arrow functions came in. You're familiar with the this variable, and it can be very problematic because it is one of these variables that it's what it's actually pointing at can change, and that can be a source of errors. But the short answer to your question is we will see arrow functions. No, I'm not going to go into them in detail at one level. They're just a simplified, cleaner version of declaring functions, simple as, and a lot of the JavaScript code that we'll be writing, we won't be too concerned with what is the current context, execution context, which is what this is all about. But yeah, we will see that syntax when we look at the, if you page through the other slides in what I've started on today, you'll see the arrow function appearing, referencing it and just showing you examples of it. But we will be using arrow functions quite a lot in our code, so
okay.
You'll have plenty of them by the end of this module. That's great. Anything else, I wonder? Okay.
Thank you.
Yeah, we all need a break, I think. So thanks for tuning in, and I will put I put it up on YouTube when I get a chance, maybe just do a tiny bit of editing on the video. And have a go at the lab, and don't be too concerned if you think, gosh, some people know a lot of JavaScript. I haven't got any, but as I said before, we're assuming nobody has JavaScript, and we're taking it from that base. Okay, I'll see you again later on. Bye for now.
Bye.
Bye.
Thank you. Bye-bye.